Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Leetcode Weekly Contest. So I hope you all had a fun contest. We will be discussing all the 4 problems today. But before we start, I would like to quickly tell you about the CP31 sheet and its newly launched version 2. So for everyone who are not aware, so this sheet basically is a set of 31 handpicked problems in each rating range from 800 to 1900 from Codeforces, and every problem basically teaches a new unique idea. So this sheet has been upgraded with a new interface where you can sync it with your Codeforces profile, so you can look at which problems you have solved and which you haven't. Apart from that, there is also a leaderboard which you can actually connect with your Codeforces handle, and you can look where you and your friends stand and compete in the leaderboard. So apart from that, every week almost 7 to 8 video solutions will be released for the CP31 sheet. So you basically do not need to waste time searching for the right set of problems or their solutions. So I hope that's well. Let's start with discussing today the problems of today's contest. So this was the first problem. The question's name is Fruits into Baskets 2, and the question is as follows. It says that you are given 2 arrays of integers, fruits and baskets, each of length n, where fruits I represents the quantity of the ith type of fruit and baskets j represents the capacity of the jth basket. Okay, good enough. From left to right, place the fruits according to these rules. Each fruit type must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Each basket can hold only one type of fruit, and if a fruit type cannot be placed in any basket, it remains unplaced. So now the question says to return the number of fruit types that remain unplaced after all possible allocations are made. If we look at the constraints, we see that the constraints are quite small. The length of the array, which is basically the value of n, is less than equal to 100. So let me explain the problem statement and let's discuss the solution. Okay, so here is the question. So basically the question says that as a part of the input, we will be provided with 2 arrays. What are these 2 arrays? One is a fruits array. So suppose the fruits array is some array 3, 4 and 7. So this basically represents the quantity of fruits. So you basically have 3 types of fruits. So the quantity of them are 3, 4 and 7 respectively. Okay, great. Apart from that, we also have a baskets array. Let me quickly check whether they are of same sizes or of different sizes. Just a second. Okay, so even the baskets array is of length n. So we are given a baskets array, say 9, 2 and 6. And the question says that we need to allot these fruits into baskets. How do we allot them? So the question says that you iterate over the fruits array from left to right. Okay. So let me start with the leftmost fruit 3, and then you put it in the first basket which comes, which has a capacity larger than the quantity. So basically the quantity of this fruit is 3, right? So that means you need to put it in a basket whose capacity is greater than equal to 3. Okay, so we need to put it in a basket whose capacity is greater than equal to 3. So the allotment procedure as per the question says that you go from left to right, search for the first basket which has a capacity of greater than equal to 3 and put it there. So let me start with 3. So let me here, okay. So I got a basket which has a capacity greater than equal to 3. So I basically put this fruit, so I basically allot this fruit to this basket. Okay, fine. So now let's start with the next fruit. So I have this 4. So now again I do the same process. So 9 is already allotted, so we cannot insert anything at 9 because it has been said that every basket will contain only one type of fruit. So the first basket already contained the first fruit, so we cannot put any other fruit in the first basket. Okay, so So 9 is gone, we can't put anything here. See that the capacity of this basket is less than 4. So that means I cannot put this fruit in this basket because its capacity is less, right? It cannot completely contain it. So we cannot put it here. So let's ignore this. Now we come here. So this is the first basket which has a capacity of 6, which is greater than or equal to 4. So that means I can allot this fruit to this basket. Okay. Now let's come to 7. So if you look at 7, you cannot put it at 9 because 9 has already been occupied by this fruit. You cannot put it in 2 because the capacity of this basket is very small. It cannot contain all 7 fruits of this kind. You cannot put it in 6 also. Why? Because there are 2 reasons. Once, the capacity is also lesser than 7 and it has been already allotted to a different fruit. So even if the capacity would have been larger, you cannot insert it. Okay. So now the question says to print. So what do we need as the output? The output is how many fruits remain unplaced. So in our previous example, how many fruits remain unplaced? So there is basically one fruit which cannot be placed, it remain unplaced. So the answer is basically 1. Okay. So the question is straightforward. The length of these arrays, fruits and baskets, which is basically the value of n is less than or equal to 100. So that means a simple brute force solution works. So what do I mean by a brute force? So basically, suppose I have this fruits array and I have this baskets array given already to me. Okay. So I basically I say I is a pointer which iterates over my fruits array. So it iterates from the indices 0 to n minus 1. And then j is also a pointer which iterates over my baskets array. So it iterates from say 0 to n minus 1. Here both fruits and baskets array have the same length n. So I write n for both of them. So now what do I see? If I see, this I is a pointer for the fruits. So is a pointer for the fruits and j is a pointer for the baskets. So j is a pointer for the baskets. That's fine. Now if I see that fruits I is less than or equal to baskets j, what does that mean? That means the capacity of the baskets is quite large, right? So that means I can put this fruit into this basket. So I can allot this ith fruit into the jth basket. So that means I can allot this. So in this case, what should I do? I know that now this basket has been allotted. So I cannot allot anything else in this basket. So the best thing would be to just mark this baskets j to 0. Isn't it? So what does that mean? That means I say that okay, I have already allotted a fruit to this basket. So let me make the capacity of this basket 0. So for the next time, I can never add any other fruit in this basket, right? This ensures that only one fruit is inserted to one basket. Okay. So there is only one fruit which is inserted to one basket. So in this example, as soon as I allot this first fruit 3 to this basket 9, I rewrite or I overwrite the capacity of this basket to 0, so that all other fruits cannot add anything into this basket. Okay. Apart from that, the idea is very simple. So this loop iterates, and if it never hits this if condition, then I know that okay, this fruit has never been allotted to any of the baskets. So I increase my counter plus and I finally return this count, which basically maintains how many fruits have not been allotted to any baskets. Okay. So let me go through the code once. So here is the code. So I have taken n and m, 2 variables here for the length of fruits and baskets, but probably only one variable works, like n is equal to m, I guess, as per the problem. So that's all right, does not make much of a difference. This CNT variable actually stores how many unplaced fruits will be there. So now I just iterate over the fruits array. So I is a pointer which iterates over the fruits array, and then I iterate over the baskets array. And if I see that okay, baskets j is greater than or equal to fruits I, that basically means that the capacity of the jth basket is greater than or equal to the ith fruit. So what can I do? I can mark this capacity as 0 and I can mark placed as true. So that basically means that this fruit has been placed, and then I break the loop. So if it is not placed, then I increase the counter, because that means that this fruit has not been has not been assigned to any of the baskets. And then we finally return the value of the count which was required to us to return as the answer. So I hope that's clear. So if that is the case, let us move to the next problem. Okay, so let's start. This is the problem number 2. So it says, so the question's name is choose k elements with maximum sum. Okay, fine. So the question says that you are given two integer arrays nums1 and nums2, both of length n, along with a positive integer k. Okay, fine. So what do we need to do? It says that for each index I from 0 to n minus 1, perform the following. Okay. Find all indices j where nums1 j is less than nums1 I. Okay, so first we need to find all indices j where nums1 j is less than nums1 I. Then we need to choose at most k values of nums2 j at these indices to maximize the total sum. Okay, so all these indices which I have already chosen in the first part, I have to look the nums2 value of those indices and choose at most k of them to maximize the total sum. Okay, fine. So I do this for every index I from 0 to n minus 1, and I keep on storing the answer of the ith operation in answer I, and I need to finally return the answer array of length n. Okay, so let me look at the constraints once. So the constraints is n is less than or equal to 10 to the power 5. So that gives us a sort of that we need to think for a linear or a log linear solution. Okay, so let us try to understand the problem statement with the help of an example. So this is the next question. So the question says that in input we will be given two arrays. So we will be given, what is the input? We will be given two arrays, nums1 and nums2, and both of these are of length n. So these are of length n. That's fine. Apart from that, we will be also given an integer k. So this is the input, and as a part of the output, we need to output an answer array of length n. So we need to output an answer array of length n. Okay, so how do we need to construct the answer array? Let's have a look. So the question says, so it can be best understood with the help of an example. So let me pick an example. So it says nums1 is 42153. So let me take this example. So it says nums1, that's 42153, and nums2 as per the problem statement is 10, 20, 30, 40, 50, and the value of k is equal to 2. Okay, great. So nums2 is 10, 20, 30, 40, 50, and the value of k is given as 2. So the value of k which is given is 2. Now how do I compute the answer array? So this is the process to compute the answer array as per the question. So understand the process well. Okay, so the answer array would also be an array of length 5. Okay, so the question says, how do I need to compute the answer array? So suppose I need to compute the first entry. So how do I compute the first entry? So the question says, look at the nums1 array. In the nums1 array, find all those indices j whose value is less than nums1 I. Okay, so I have a 4 here. So which are those indices whose value is less than nums1 I? So 2, 1 and 3. These are the values which are less than 4, right? So I have these three indices. Which are basically less than nums1 I. Okay. Now look at their corresponding j values, their corresponding nums2 values. So of all these indices whose actual value was less than nums1 I 4, the corresponding nums2 values are 20, 30 and 50, right? Now among these, pick at most k of them and return the sum. So out of these values 20, 30 and 20, sorry, so out of these values 20, 30 and 50, which are the two largest values? Because why 2? Because the value of k is 2, so I need to pick two largest values. So which are the two largest values? 30 and 50, right? What is their sum? 80. So that will be my first entry. Okay, so this is how the answer array needs to be constructed. Let us try to construct the entire answer array and you will understand what is the process. So let me do it again. So basically this is 2. So find all indices. So first find all indices in nums 1 which are less than 2. So there is only one index which is less than 2. So which is this 1. What is its corresponding nums 2 value? 30. So there is only one value. We can pick at most 2, but we get only 1. So we pick only this one. We have no other choice. And so the answer to this entry is 30. Okay. Now let's start with this 1. So pick all indices in nums1 array which are smaller than 1, but there is no index smaller than 1. So if there is no index smaller than 1, we will get nothing. So the sum is basically 0. Okay, fine. So now let's start with 5. So first find all indices in nums1 which are less than 5. So remember all these indices, all these values 4, 2, 1 and 3 are less than 5. 5 is the maximum value in nums1, right? So now look at their corresponding nums2 values. We have got a 10, we got a 20, we got a 30 and we got a 50. Okay. Now since the value of k is 2, pick the largest two of them. So the largest two is 30 and 50. So what is their sum? 80 again. So the sum is again 80. Okay. Similar process for 3. So which indices are less than 3? So there are two indices less than 3. Look at their corresponding nums2 values which are 20 and 30. So we pick both of them because the value of k is 2. So what is the sum? The sum is 50. So this is the process. How do we need to construct the answer array? Okay. Now remember that we cannot do a simple brute force here. Why? Because the value of n is given. The value of n is given 10 to the power 5. So since the value of n is 10 to the power 5, if I do a simple brute force, that would mean I iterate over all indices I and then I check which indices j are less than I. So basically for every I from 0 to n, for 0 to n minus 1, I basically again iterate over the array. So that will be big O of n square, right? So a brute force would be big O of n square and it will fail. So we cannot think about a brute force solution. We need to think something more optimal. Okay. So here is the idea. Let me write the test case once again. Nums1 is 42153. The value of k is 2 and nums2 is 10, 20, 30, 40 and 50. Okay, fine. So my idea is that since I need to consider all those values which are like, for see what am I actually doing? Like for 1, I know that there is no value I can pick at nums2 because 1 is the minimum element in the array, right? Then for 2, I have a choice of picking this 30. For 3, I have a choice of picking this 20 and this 30 both. For 4, I have a choice of picking this 20, this 30 and this 50. And for 5, I have a choice of picking all these values 10, 20, 30 and 50, right? So that means it makes sense if I try to iterate. So if I iterate in this similar left to right fashion, I equal to 0 to n minus 1, it is not much helpful. Rather, it will be more helpful if I try to iterate over the nums1 array in increasing order of their values. That means I first go to this 1. Okay, I first go to this 1, I process this 1. Then I go to this 2. Then I go to this 3. Then this 4 and then I come back to this 5. If I do that, the benefit will be that I will be basically, since I am iterating over increasing order of values in the nums1 array, so my basically the allowed set, So basically the allowed values which I can pick from in nums2 will be incrementally increasing. So that will help me in improving the time complexity. So what is the idea? So the idea is something like this. So now I'm trying to find out the answer array. Okay. So my answer array is initially empty, but now I will not populate the answer array in this left to right fashion, the way I did before. Rather, what will I do? I will first look at what is the smallest value in nums1. So I'm trying to fill values one by one in nums1. Okay. So nums1 is like this. And then I know the smallest value is 1. So I fill this one. Okay. So now I also have a nums2 here. And then I have an answer here. Now I will, since I am filling these values in increasing, like I am filling these numbers in increasing order of their values, I do not need to check which values are smaller than 1. I know everything which has come before is smaller than 1. So nothing has come before. So in that case, the answer is 0. So the answer is simply 0. Okay. So in nums2, I basically maintain a bag. So I maintain a bag of which numbers I can take from. So initially this bag is empty. Okay. So now I know that the answer is 0. But now in the next iteration, what do I know? In the next iteration, I know that okay, this 30. For in the next iteration, I will start processing this 2, right? So when I will process this 2, this 1 will be lesser than 2. That's for obvious, because I'm iterating values in increasing, like I'm populating this nums1 in increasing order of their values. So what is the corresponding nums2 value of 1? That is 30, right? So let me fill 30 in this bag. So that is the idea. So let me fill 30 in this bag. And now let me reiterate the process. Okay. So now I am populating 2 here. I have already populated a 1 before. Now I populated 2 here. Okay. So now the best thing is I do not need to check which values are smaller. I do not need to use a loop to check which values are smaller. I already have a bag which stores 30. And then I have this answer array. Okay. And I have a 0 already filled here. So I will look from the bag that okay, my value of k is 2. That means I can take 2 maximum values from this bag. So what is the 2 maximum values? Okay, I get only 1. Let me put this 30 here. Okay. So this is the best thing, that I am maintaining a bag of number. First of all, I am iterating in increasing order of values in this nums1 array, and then I am maintaining a bag for nums2. Now what I will do next? I will update this bag. So I first populate my answer and then I update this bag. How do I update this bag? I know that in this iteration I have filled a 2 here, right? So what is the corresponding value of 2 in nums2? So the corresponding value of 2 in nums2 is 20. So that means let me also fill this 20 in this bag. Because in the next iteration I can basically also pick a 20, right? So let me also put a 20 in this bag. So what will happen in the next iteration? So in the next iteration nums1, we will be processing a 3. So I have a 2 here, I have a 3 here. In my nums2 bag, what values do I have now? In my nums2 bag, I have a 30 and I have a 20 already sitting. Now I will first populate, look what do I do at every iteration? At every iteration, the first thing I do is I populate the answer array. So this is 0, this is 30. First of all, I need to populate the answer array. Okay, so this iteration is for this 3 corresponding to this 3. So I first populate the answer array. How do? I look into this bag and look at the 2 maximum values, because the value of k is 2. Add their sum, find their sum and put it here. So what is the value? 50, right? Sum is 50. Now, after I have populated this answer array, I update the bag. How do I update the bag? I know that this iteration was for this 3. So I look that okay, what is the corresponding value of the 3 in nums2? So what is the corresponding value of 3 in nums2? It is 50, right? So I put this 50 in the bag. Okay. So now I come and put this 50 in the bag. Okay, now there is a catch. So from this bag, I will, since the value of k is 2, I will pick only two, at most 2 values from the bag, right? So it does not make sense keeping more than 2 elements in the bag. So what do I do? I simply erase this 20 off, because 20 is the minimum element and I need to keep the sum maximum. So I erase this 20 off and insert the 50 into the bag or in the set. So this 20 gets erased and this 50 comes here. 50 comes into the bag. So this is the basic idea. So in the next iteration, look what happens. So in the next iteration, we will be processing 4. So in the next iteration, we will be processing a 4. So I have a 4 here, a 2, 1, a 3. Now my what does my nums2 bag contains? My nums2 bag contains the values 30 and 50. 20 was already removed in the previous iteration. So we contain a 30 and a 50. And now I have to, what do I do? The same thing. First I populate the answer array. Okay. So there were some entries which were initially populated. So now first of all I populate the answer array. So how do I populate the answer array? I look at the 2 elements of the bag and I compute the sum. I store it here. So the sum is 80. Okay. Now I update the bag. How do I update the bag? So I look at what is the corresponding value for 4 in nums2. So what is the corresponding value of 4 in nums2? 10. Okay. So I try to insert this 10 into the bag. But then I see that, okay, there are already 2 elements in the bag and even the minimum element 30 is larger than 10. So I just throw away this 10. Okay. Instead of 10, if this would have been 90, then I would have erased this 30 and inserted this 90 into the bag. Okay. So I maintain a bag of the top k values. So this is basically a bag which contains the top k values. Okay. And I iterate nums1 in increasing order of their values so that I do not need to compare. So this maintaining this order actually helps me that when I am computing the bag, I already know that all the values for which nums2 value is there in the bag, their nums1 value is definitely lesser. So that is what I am doing. Okay. So now this was the solution, but then there is a small catch which I will like to explain. What if there are repetitive values? So suppose I have multiple 2's and then a 3 in nums1. Okay. So I have multiple 2's and then I have a 3 in nums1. And suppose my nums2 array looks like this. That it is 20, 30, 50 and a 90. Okay. And I need to compute answer. And suppose k is equal to 1 for simplicity. So now here there is a problem. What problem? So we will try to process this in increasing order of values, right? So first of all, say I process this 2. When I process this 2, what was my bag? My bag was empty. Okay. So in my answer array, I populate a 0. So if I try to maintain my answer array, so initially my bag was empty, so I populate a 0. Okay. But after populating the 0, I look at its, what does my logic say? That I look at my corresponding nums2 value 20 and I put it in the bag. So I put 20 in my bag. Okay. So now when I come to the next value 2, then what do I see? I see that, okay, now first of all I need to update the answer array. But when I update the answer array, I look that, okay, there is 20, I need to pick k equal to 1 value. So I basically put 20 here. But putting 20 here is wrong. Why putting 20 here is wrong? Because I need to consider only those values which are exactly strictly less than 2. So when I am taking, so if you think about the logic, I need to pick only those values which are strictly less than 2. So there are no value which is strictly less than 2. So actually the answer should be 0 here also. Okay. But in my logic, just after I insert this 20, I put this into the bag. So how do I handle that? Handling that is actually very simple. You maintain a pending vector. So what do? You maintain a vector of pending values. Okay. So whenever you find all these values which are equal, so whenever you see that, okay, there are many 2's, so you do not put these 20, 30 or 50 then and there in the bag. You put them in the pending vector, you wait for some time, then in the next iteration you see that, okay, I am going to jumping to a different value. You put your entire pending vector in the bag and clean this pending array. Okay, so this is the idea. I hope it becomes a bit more clear if I show the code. So here is the code. Look, the idea is simple. So I maintain a multiset. So this multiset S is basically my bag. Okay. So now so n is basically the length of the array, and this is a vector of pairs which I have named order. So this basically I will use for sorting the nums1 array. So I sort the nums1 array. So the nums1 array is sorted on the basis of their values, and I've maintained this sum variable which basically maintains the sum of the top k values. Okay, and then this is the pending array which I already discussed, and then this is the answer array. Okay, now I'm basically processing each element of nums1 one by one. Okay, so now after I process, I basically come and see, I try to extract the index, and then I try to extract the value. Okay, and then I push it in pending. Okay, now if I see that this order and the previous order values, both of them are same, that means we are look at repeating values. So we have already pushed it in pending. We will continue. We will not update. We have updated the answer array. So that has been done. We have pushed it in pending. But if I see that the value has been equal, then I do not update my bag. I do not insert it in my bag. I keep it in my pending, so that later I will take up things from my pending and put it in my bag. So later, whenever I see a different value, then this if condition does not hits, then what will I do? I will simply go on and then I will basically update my bag. How do I update my bag? It's very simple. So I'm basically looking at every value in my pending array, and then if I see that, okay, if the size of bag is less than k, then there is no issue. If the size of bag is less than k, I just put it because I can take that value. But if the size of bag is not less than k, then I see that what is the smallest value in the bag. Is the smallest value in the bag lesser than the current value? Then I throw away that smallest value and put the current value into my bag, and I update the sum variable accordingly. Finally, I clear the pending array and return the answer. So I hope the logic is clear. So if that is clear, let's start with the next problem. Give me a second. Yes, so let's start with the third problem of the contest. It says fruits into baskets 3. So it is the exact same question as we have discussed in problem 1, where a simple brute force solution passed, apart from the fact that now the constraints have been made a bit large. So now the value of n is less than equal to 10 to the power 5. Okay, so I will not explain the problem statement once, as we have already done that a bit before when we were explaining problem 1. But the basic idea is that when we solve the problem in problem 1, then we wrote a big O of n square code, right? We first of all iterated over the fruits array, then we iterated over the baskets array and found out the correct basket, or the basket whose capacity is larger than the quantity of the fruit. But this is a brute force code which will give TLE if my n is now set to 10 to the power 5. So we need to think somehow of an optimal solution. Okay, so since the value of n is less than equal to 10 to the power 5, that means we need to think about an expected a code whose expected time complexity is better, so that we get an AC. Okay, so let us try to think about the problem. So what should I do? So basically the question says that I have this fruits array. So I have this fruits array. So suppose these are the fruits f1, f2, and it goes on till fn. Just a second. Yeah. So this is my fruits array, and then there is a baskets array, right? There is a baskets array which contains capacities. So every basket has some capacity C1, C2, and it goes on till Cn. and I need to find the leftmost basket. So I need to find the leftmost basket which has a capacity. So let's think about this problem independently for every fruit. Okay, so suppose I am processing the ith fruit. So I am processing the ith fruit, for example. So this is the ith fruit I am processing, and we will think the problem independently for every fruit. So what is happening? So I need to find the leftmost basket Cj, which is greater than equal to the quantity of this fruit Fi. Okay. So I need to find the leftmost basket which is whose value is greater than equal to Fi. How can I do that? Now think about this. Think about this. Whenever we need to find the leftmost or the rightmost elements, then there is always a monotonicity property, right? So there is a monotonicity property involved if you think about it carefully. So what does that mean? So that basically means, what I basically mean is that, okay, if I have this large baskets array, okay, if I have this large baskets array and I say that, okay, I basically have a basket in this region. Suppose I say that, okay, there is a basket present in this region. There is a basket which is present in this region which can hold the fruit. So there is a basket in this region which can hold the fruit Fj. Then I also know that, okay, then there must be a basket in this region which also holds the fruit Fj, right? Because this region is a subset of that region. So this is called a monotonicity property. So basically, if I ask you that, okay, does there exist a basket? So for every index, if I keep on asking you that, okay, does there exist a basket which can hold Fj? So does there exist a basket up to this which can hold Fj? Say you say no. Then does there exist a basket up to this which hold Fj? For example, you say no, and you keep on saying no. But then there comes a moment where you get the first basket whose capacity is greater than equal to Fj. You say yes for it, and then for all other indices you keep on saying a yes. Okay. So basically, so that means this problem has a monotonicity property. Why I am explaining this to you is, whenever you see such a pattern that you first get a lot of no as responses and then you keep on getting yes as responses, then what you can think of actually is binary search. Binary search comes very handy whenever you have a monotonicity property in your problem. So here I need to find the smallest index j such that I have a basket which can fit the fruit I, right, in that region 0 to j. So that means since I need to find the smallest index j and the monotonicity property holds, what I can do is I can try doing binary search. Okay. So now, so what is my idea? My idea is that I will go for I equal to 0 till n minus 1. So I am basically processing the ith fruit. So I am processing the ith fruit. Okay. So I need a basket. With capacity. So I need a basket with capacity greater than equal to Fj, right? So that basically means that I need to find the smallest index. So basically, if this is my baskets array, suppose this is my baskets array and this is the first index j. Suppose this is the first index j which is greater than equal to the Fi, whose capacity is greater than equal to Fi. So what do I need? I need to find the smallest index whose basically prefix maximum. The prefix maximum of the baskets array is greater than equal to Fi, right? So this is how I will implement the check function. Because look, what does this mean? That this is the first index whose value is less than equal to Fi. That means that all these indices, the value was strictly less than Fi, right? So if I need to check in very quick time, so one thing you can check that, okay, which is the first index, like is this the first index whose value is greater than equal to Fi? Then you can do a simple for loop and check, but that would be time consuming. What I am saying is, why not compute prefix maximums? So keep on computing prefix maximums and then check And then if you need to find out that okay, does there exist a bag in the first j up to j which can hold fi, then you basically need to check that okay, is the prefix maximum from 0 to j greater than equal to fi? Because if the prefix maximum from 0 to j is greater than equal to fi, that means there is some bag whose capacity is greater than equal to fi. Okay, just for clarification, if you guys do not know what prefix maximum is, it is simply just the way we do prefix sum, right? So if you remember prefix sums, so there we do that okay, pi is nothing but say a0, a1 and it goes till ai, where ai's are the elements of the array. Similarly, prefix maximums would be that you basically maintain a prefix array pi which stores max of a0 till ai. Okay, so the first idea is that okay, I need to do binary search, I need to implement check function. That means I need to check does there exist a bag in the first j indices where I can where basically I can store where a fruit of where basically I can store the ith fruit or not. So does there exist a bag in the first j positions which have a capacity greater than equal to fi or not? I can do just by checking that okay, is the prefix maximum or the maximum value from 0 to j greater than equal to fi or not? Because if the maximum value is greater than equal to fi, that means there exists some value greater than equal to fi, right? But then here comes a problem. The problem is that if you recollect in the first problem what we did, if you recollect the solution to the first problem, what we did, so we had this baskets array, right? C1, C2 and it goes till Cn, and suppose this is the jth basket Cj, and suppose I have taken this ith fruit and I have allotted this to Cj. Okay, fine. Now after allotting this to Cj, I also need to ensure that I do not allot any other fruit. I also need to ensure that I do not allow any other fruit to Cj, right? This I cannot allow. So what do we need to do? So in problem 1, if you remember, we need to reinitialize. We need to reinitialize or override this value of Cj with 0. So just after I allot a fruit fi to Cj, I will overwrite its value with 0. That is what I would have done in the first problem. But the problem now here is that if you compute prefix maximums and then if you overwrite some value in between, then you need to update the prefix maximum or you need to compute the prefix maximum array once again. That would take big O of n time. So that would be very time consuming. So here is the catch. So that means we need a data structure where what can I do? I can compute prefix maximums very fast. I can compute prefix maximums fast. This could have been done with prefix maximum array, but then I can update array values in between. So we need to handle both of these operations very quickly. We can't run a for loop to do this. And the solution to do this is very handy: segment trees. So people who are familiar with segment tree must understand that segment tree is a data structure which can actually help you to find range queries. So prefix max is a range query in log n time, and then you can also update in log n time. Okay, so what is the solution? So the solution now is very simple. So what you basically, so you are given this baskets array C1 to Cn, you construct a segment tree st out of it, which basically gives you the maximum of any range. So whenever I give you a prefix 0 to d, you can tell me its maximum in log n time. Okay, you can tell me its max in log n time. Okay, so this is a query which it can handle. Apart from this, what it can handle, I can set that okay, set index idx to 0, and it can also handle this in log n time. Okay, So if the segment tree can handle these two operations, then for every fruit, what I can do is I can do a simple binary search. I do a simple binary search. I use the segment tree to implement the check function, and then I simply check which is the smallest index j, such that the maximum prefix maximum of that prefix is basically greater than equal to fi. So let me show you the code. Okay, so here is the code. So as I said that we first maintain or create a segment tree out of the baskets array. Okay, and this max is basically this function max a comma b. So I use the maximum function to create the segment tree on the baskets array. Okay, now what do? I implement binary search. How do I implement binary search? While implementing binary search, I do it independently for every fruit. So this is the pointer to the fruits array I equal to 0 till n minus 1. Okay, now I am doing a binary search. I set my low to 0, I set my high to n minus 1, and I set my answer to n. So what does it mean when I say that I set my answer to n? So basically, if the fruit is not allotted to any of the baskets, then my answer remains at n. So if the answer remains at n, that means the fruit is not allotted to any of the baskets. And since we need to finally print the total number of fruits that remain unplaced, so I basically, if the value of answer is n, I will increase my counter by 1. Okay, so now I do a simple binary search. I check. So I go to this mid value. I check that, okay, from 0 to mid, does there exist a basket where I can place my fruits array? If yes, then I set my answer to mid, and I push my high inside the range to mid minus 1. Otherwise, I increase my low to mid plus 1. Okay, so how do I check this? So checking it is very simple. I just check that, okay, is the prefix maximum greater than equal to fruits I or not? Okay, so that is, see, I just check that, okay, I basically check that, okay, is the prefix maximum greater than equal to fruits I? So if that is the case, then okay, we can find a basket in that range which can hold that fruit. Apart from that, if the value of answer is equal to n, so that basically means I have to increase my counter by 1, because that fruit could not be allocated to any basket. Otherwise, I update my answer array. I update my answer array with 0. I update the answer index with 0. So basically, what do? In the baskets array, this answer was the index where I will allot the ith fruit. I can make its capacity 0 so that no other fruit gets allocated to it. So I hope the logic is clear. If that is the case, let us start. Let us start with the last problem of the contest. So here is the problem. Okay, so let's start. So the question says that you are given an integer n which represents an array nums containing the numbers from 1 to n in order. Okay. Additionally, you are given a 2D array conflicting pairs where conflicting pairs I equals a comma b indicates that a and b forms a conflicting pair. Great. Now the question says that remove exactly one element from conflicting pairs. Afterward, count the number of non-empty subarrays of nums which do not contain both a and b for any remaining conflicting pair ab. Okay. So now the question says that return the maximum number of subarrays possible after removing exactly one conflicting pair. Okay, and the value of n is greater than equal n is less than equal to 10 to the power 5, and the number of conflicting pairs is less than equal to 2n. So let me explain the problem statement once. So this is the question. So the question says that you are given as an input, you are given an integer n. So what does this n represent? It basically represents that you have an array 1 till n, for example. Okay, so you have this array from 1 till n, and the value of n is less than equal to 10 to the power 5. That's the constraints of the problem. Fine enough. Now the question gives us some conflicting pairs. Okay, so we have a conflicting pairs array. So suppose, for example, 3 and 6 is a conflicting pair. Okay, so let me write this a bit more. So suppose we have 5, we have 6, we have 7, and then it goes till n. And suppose it has been given, so there are many pairs which are given as input. 3 and 6 may be a conflicting pair, and so on. There may be many conflicting pairs. So the question says that you need to find the number of subarrays which does not contain any conflicting pair. So that means, suppose you can take this subarray, okay, because in this subarray there is no conflicting pair. But you cannot take this large subarray. Why? You cannot take this large subarray 2 to 7 because here you have a conflicting pair 3 and 6 inside. So you cannot take any subarray which have both the elements of the conflicting pair inside them. Okay. So by this way, say you count the number of subarrays. Now the question says something different. The question says that you have been given power. Okay, you have been given power to remove one conflicting pair. So you can remove this, you can remove this, or you can remove any one of them. Now the question says that you need to maximize the number of subarrays. Okay, so we need to maximize the number of subarrays. That if I remove 3 and 6, I count that, okay, so suppose I have given many conflicting pairs. Say I have given P1, P2, and so on. So first of all, I remove P1. So I keep every conflicting pair as it is. I just remove P1 and check how many subarrays can I count. Okay. Then I remove P2. So I keep everything as it is. I just remove P2 and check how many conflicting pairs can I count. So by this, in this procedure, I need to return the maximum number of conflicting pairs I can count by removing exactly one conflicting pair. Okay. So this is the question. So now let us try to approach the solution. Okay, so before approaching the solution, so before worrying about which conflicting pair we need to remove, okay, give me a second. Yes, I apologize for the delay. Okay, so let's start discussing the problem. So my idea is that before trying to remove one conflicting pair, first try to keep all conflicting pairs as it is and try to find out the answer. Okay, so I have this array 1 to n. I am not removing any conflicting pair and I will try to find out the answer. Okay, great. So now how can I find the answer? So my idea is simple. Let me iterate in reverse order from n till 1. Okay. So let me run a reverse for loop for I equal to n till 1. Okay, so what will I do in this for loop? In the ith iteration, so I am sitting at this position I. Okay, in the ith iteration, I will try to count the number of subarrays. I will try to count the number of subarrays which start at I and have no conflicting pairs. Okay, so basically if I do this for every I from 1 to n, then that basically counts the total number of conflicting pairs, right? Because at the ith iteration, I am counting the number of subarrays which start at I. So every subarray starts at some index. So if I take all possible indices and count the number of subarrays which start at all those indices, then I basically count the entire answer. Okay. So at the ith iteration, what do? I try to count how many subarrays start at I and does not have any conflicting pair. Okay, how can I do that? So my idea is that, okay, basically there are many conflicting pairs, right? So suppose this is a conflicting pair, this is a conflicting pair, this is a conflicting pair. There are many conflicting pairs A comma B in this region. Okay. So this is A1, B1, this is A2, B2, and so on. Okay, fine. So now, if I need to, so which subarrays can I take? which subarrays can I take which does not have any conflicting pair? So my idea is that if you look at all these segments which are to the right of I, so you take all these segments which are to the right of I, and I start at I because I'm counting number of subarrays which start at I, then I can pick all those indices. So suppose this is B1, this is B2, this is B3 and this is B4. I need to take the smallest index R. So suppose the minimum of their endpoints, is this point min R. Okay. So now I can take only the subarray from I till this min R, right? I can only take those subarrays which start at I and end at some position less than equal to min R. Why? Because min R is the minimum rightmost position, right? So min R is the minimum rightmost position. So there is some conflicting array like this. There were many conflicting arrays. So there were many conflicting arrays like this, and since this was the minimum, so this was the, since min R is the minimum rightmost position, so there exists a conflicting pair which is like this. Fine. Now, as if I exceed my subarray beyond this min R, then I will be basically taking this conflicting pair inside my subarray, which is not allowed. So in order to ensure that no conflicting pair is inside my subarray, I will find the minimum of these endpoints, and then what will I take? I can take only from I till minimum R minus 1. Okay. So how can I find the minimum? Finding the minimum is actually easy. What we can do is we can maintain a set. We can maintain a set of active segments or conflicting pairs basically. So basically what do? I am iterating I from n to 1, right? When I'm iterating I from n to 1, I store this information in a data structure that which conflicting pairs start at I. So when I come at I first push all these segments which start at I into my active segments. So this active segments is basically a set which basically stores all these segments, right? So now if I have all these segments already stored, I can keep their minimum endpoint stored in a set, and then I can take the begin iterator. So I will get the minimum value of R. So that is fine. So computing the base answer is fine. Okay. So here comes the catch. So I have this index I. Okay. I have this index I. There are many active segments here. So this is an active segment. Suppose this is an active segment. Suppose this is an active segment. And this is an active segment. Okay. And this is the corresponding minimum R value. So this is my minimum R value. Right. So this is my minimum R value. And so if I need to count number of valid subarrays which start at I can go from I till min R minus 1. I cannot include this min R because if I include this min R, I will be basically taking this conflicting pair inside my subarray, which is not allowed. Okay, fine. Now my question is that what do we need to actually compute? So basically we have computed the base answer. What is base answer? So I basically say that okay, my base is nothing but what is the answer if no conflicting pairs are removed. So if no conflicting pairs, if no CPs are removed, no conflicting pairs are removed, then what is the answer? This I have already computed. I have showed. Basically you go from run a reverse for loop for I equal to n to 1. At every index I, you basically look at what is the minimum R value. This you can do easily by maintaining a set, and then you basically compute the answer. Okay. So finding the base answer is easy. So basically finding the answer when no conflicting pairs are removed is easy. But when you remove a conflicting pair, then you basically can get some improvement, right? So basically what improvement I can get? So what happens if I remove this conflicting pair? So think about this, that if I remove this conflicting pair, what I can actually do is, if I remove this conflicting pair, now my minimum R value shifts from this position to this position, right? Because this is the second minimum. So my idea is something like this. So I have an index I here. So I have an index I maintained here. And then there are set of active segments, right? and I have already computed the base answer, so do not worry about that. Okay, so now this position, now think about this. This position is my minimum R, right? And this position is my minimum R2, for example. So this is minimum R2, right? Now what my claim is that, okay, I have already computed the base answer, but now let me maintain an improvement array. So let me maintain an improvement array. So what does this improvement array stores? So basically for every segment, let me store that, okay, what more answer can I get? What more subarrays can I get? What is the what is the improvement I can get if I remove this conflicting pair? Okay, so for every conflicting pair, I have an entry in the improvement array. Okay, so now look into this. For this index I, if you look into this array, this conflicting pair, and if you remove this conflicting pair, so initially you are taking subarrays up to till min R minus 1, right? But now if you remove this conflicting pair, you can take all subarrays till min R2 minus 1. Okay, so what is the improvement you get if you remove this conflicting pair? The improvement you get is, what is the improvement you get? The improvement you get is minimum R2 minus min R. So this is the basic idea of the solution. So the idea of the solution is very simple. So it is simply this, that okay, when I'm processing index I got some min R. So this min R is basically the constraint. It is blocking me. So it is basically blocking me to choose subarrays only in this range. That means if I delete this conflicting pair, I can get an improvement. How much improvement? From min R till minimum R2. Like I can take all these subarrays which start at I and end up at an index between this min R and minimum R2. So this is the region, this is the space which I get an improvement if I remove this conflicting pair, right? Now note that apart from this conflicting pair, if I remove this, suppose I remove this conflicting pair, if I remove any other conflicting pair, I get no improvement. I get zero improvement. Why? Because even if I remove this conflicting pair, this min R remains there. So I can still choose subarrays only in this range. It does not matter if this is present or this is not present. So this is the idea, that when you are trying to compute the improvement array, for every index I, you will get only one segment. You will get only one segment, right? For which you need to consider the improvement. For all other segments or all other conflicting pairs, their improvement is zero. So you do not need to even consider them. That is the reason the time complexity is remains optimal. Why? Because for every index I, for every index I, so for every index I you go from 0 to n, you do not need to consider the improvement of every conflicting pair. So it is not n into m. So it is not n into m. Why is it not n into m? Because for every index I, you just need to count at most one. You need to count the improvement of at most one subarray, one conflicting pair. Which conflicting pair? The conflicting pair whose R is minimum, right? That is the reason the time complexity becomes n plus m instead of n into m, and it passes the time limits. Now this simple thing, that okay, suppose there is no unique minimum. So say for some index I have two active segments which both are of min R, which have the same minimum R value. Okay, so suppose they have the same minimum R value. Then do I need to consider improvement for both of them? No. If you have two segments which have the same minimum R value, then the improvement of both of them is zero. Why? Because even if I remove this guy is still there, and so we do not get any improvement, because when both the segments are present, we can take subarrays only in this range. But if I delete this one, then also I can take subarrays only in this range. So there is no improvement. So that means if there is no unique minimum, then we do not need to count the improvement for any of the arrays. Okay, so now let me show you the code. So I hope the solution is clear. So this will help you to build up a solution, and you can try writing the code yourself. So usually in these type of problems where the logic becomes a bit complicated, it's good that you try to understand the solution first and then try to code it up yourself, because understanding the code from scratch which anyone else have written may be a bit overwhelming. Okay, but the idea is simple, that okay, I have this m is the conflicting pair size, and then I have maintained this start array. So what does this start array do? So start I, so basically start I stores the conflicting pairs which start at index I. Okay, so I consider all these conflicting pairs. I look at their L and R values. So L is minimum, R is maximum, and then inside of start L, I push the R value and the corresponding segment, like what is the index of that corresponding conflicting pair. Okay, apart from that, I have a set of active pairs, and I also maintain a count vector. So this count vector basically maintains, so count I maintains that how many segments are there which end at index I. So why is that helpful? So basically to handle these type of cases. So in this case, I can just check what is the value of count min R. Okay, so what does count I store? It stores that how many segments end at index I. So if I see that okay, count min R is greater than equal to 2, then there is no improvement, I just skip. If the count min R is exactly equal to 1, then only I need to consider the value. Okay, so now the idea is simple. So here I will compute the base array, and this is my improvement array. So now look what I have done. I have iterated from n till 1. Okay, so now when I am iterating from n till 1, I first of all need to update my active set of segments. So okay, so all these indices, so everything which has started at I have to insert them at active. Okay, so I do that. I also update my count array. So everything which has ended at R, I insert them. So that is done. Now here comes the main part of the code. Okay, so the first part is easy. What if active is empty? So active is empty means there are no segments to the right. If there are no segments to the right, then what is my base answer? So my base answer is basically take all segments which start at I. Okay, so you start at I, and then it can end from anywhere from I till n minus 1. So number of such segments is n plus 1 minus I. So it's trivial. Okay, otherwise what do I do? Otherwise I compute my minimum R. So that is the min R. Okay, so min, and I add that to my base value. Okay, so this is the min R value which we are referring to, the minimum of all the right indices. Okay, now if I see that okay, the count is 1, if the count is greater than 1, if the count is 2 or something, we know that there were no improvements, so we do not need to consider them. Okay, but if the count is 1, what do? I simply find the second minimum. Okay, so we find the minimum R2, so we find the second minimum, and then I have also kept these pairs, and then I've stored this index, like which minimum, this minimum R corresponds to which index, so that I can update its improvement array. Okay, so in the improvement array, I have increased the improvement of that corresponding conflicting pair by the difference of them. So it's minimum R2 minus minimum R1. Okay, so this is how I have updated the improvement array. Finally, I return base, which is my base answer, which will be already present even if no conflicting pairs are removed. And this is the maximum of all improvements. So basically for every conflicting pair, I take the maximum of which, I basically take the maximum of which conflicting pair I need to remove. So the maximum improvement I can get. Okay. So I hope you have understood the solution. That was all from my side. Thank you.